Hello everybody, my name is Hello. In this video, we're going to be looking at a design pattern in Python which is called as a generator pattern. Now, generator is maybe it's quite tricky, but also it's a very simple concept. Let's go over that in this video. Let's talk about what generators are, how you can create your own generators, and why generators are used. Now, generators are a special type of an iterator in Python. It allows you to yield values one at a time instead of returning all the values. Okay, that statement might be a bit overwhelming the first time you hear it. What does this yield mean? Okay, let's take this function. Okay, what does this function do? Nothing. It takes a list as a parameter and it returns a list at list itself. Okay, now I'm going to call this function and I'm going to print the list. What happens when I run this function? Well, you're going to get 1, 2, 3, 4. That is the list right here. Well, that's awesome. Okay, now think about this. Instead of this being something like this, let's say something like this. In that particular case, instead of this being 4 elements, it's now 11 elements, right? What will happen here? Well, all 11 elements will get printed. That means all 11 elements will be returned in a single call. Now, instead of 11, if I have 11 million elements, for example, all of these 11 million elements will be returned in a single call, which means there's everything, the entire data is loaded into memory. And this becomes a problem when I don't really need the entire data at the same time, because I might use it in different ways, right? Let's say I want to just take a reference of this particular list, whatever that's being returned, and I can just call element whenever I want. I don't want to load all of these million elements. Just take it one at a time. How do you do that? Well, that's how generator comes in and the concept of yielding comes in. So instead of this, let's put another function, okay? And the listing. Now, I am going to yield instead of returning. I'm going to do this again. Yield LST of 1 and I'm going to yield LST of. Wait, how come I'm able to yield 3 times? Because when I return even twice, you can see the return after the first return becomes useless, because once you do that, the call goes back to the main program from the function and we lose control about all of that is below. Those are code which doesn't get executed. How am I able to yield multiple times here? Well, that means you can return multiple values. And how do you take these values? So when I just put this function, okay, so I'll just go back to these 4 elements for now and I'm going to do yield of a list of 3. Okay, now I am going to create another, I said gen ob, that's the variable I keep. It'll make sense in a bit. I'm going to go ahead and call this function too with my same list. Okay, now tell me what will happen if I print my gen ob. Well, you can see something called a generator object has been created at function. Well, that's very interesting. That's why it's the name I have put as gen ob. What does this do? Well, I print this one, nothing happens, right? Now, this object, now when I print this one, it does not print the values. It does not return the entire list as it does in the first function when we're just using lists. Instead, I'm getting an object of a generator. Okay, so how do I iterate over these objects and how do I view these objects now? Well, I have 4 yields, right? Let's say I am going to do next of gen up. Okay, and I'm going to just print, just say this something as a, and I'm going to this print this value a. What do you think will happen? Okay, it prints 1. 1 is what? List of 0. That means this yield is cut. Now, I am going to give you a very interesting question now. I have this function here. I am going to send this one here. If I run this code again what will happen? This same thing will be sent over here and it will be returned back to me. So I'll get the same answer regardless of how many times I run a function with return. Correct? In this case at least. Now, what will happen if I run the same function again? What? It prints 2. What is 2? 2 is the first element. So it's calling this. So it has ignored this and gone here. It has not ignored. What it is basically doing is it has executed the first yield. Then it'll move on to the next yield. So every time you call this function, it will go to a different yield. Okay, so I run this again. it'll print 3. I run this again, it'll print 4. And what happens if I run this again? It throws me an exception called stop iteration. Oh, hold on, hello. This is too much information. What is this next doing? What is this stop iteration doing? And how am I able to get different values every time I call the same function for some reason? Okay, let us break this down. I see you in the whiteboard. Okay, so let's just explain what happened. So this is the data that we're working with. There are 4 elements here, 1, 2, 3, and 4. Now, if I use this as a list, what will happen is when I call as a list, this entire value 1, 2, 3, and 4 gets returned. Okay, but what if I don't use it as a list, and what if I use it as a generator? I use it as a generator. Well, in that case, what gets returned is a generator object. None of these data gets returned with this. All of this gets is the object. So the entire data that we are dealing with here does not get loaded into memory. Here, since we are returning all 4 values, the entire data is loaded into memory when you're returning that. Okay. Now, once I get the generator object, how do I access these data? Now, imagine, okay, what the generator object is. It's the same data, okay? You have something like 1, 2, 3, 4, okay? Except you don't know what 2, 3, and 4 is. That is something that is not loaded into memory. What is loaded when this generator object is created? Only 1 is loaded into memory. And how is that 1 referred to as? If this object I call as A, next of A would be 1. Okay, so how do I get 2, 3, and 4? Hello, if that's something that you're asking. Well, using this function again. Now, what happens when I call this next of A again is it will lazy load the next number after 1. What does lazy loading mean? Loading on demand. So once I ask for next of A, only then will you load 2. Okay, now my pointer is at 2, and maybe I can give a different color for the pointer. Okay, then what I'll do, I'll use the same function again. I'll do next of A. A is the generator object that we already discussed, right? Then I'll lazy load the next number, and this will be 3. Okay, so now my pointer would go to here. This will be my reference pointer. Then what will I say? Load the next value. So I'll do next of, and then there I load 4. Okay, now what happens here? The pointer comes here. Okay, in this case, I am going to load next of A. Next of A. What happens? Well, there's nothing here to load. Therefore, nothing will load. Okay, that's as simple as that. And when you're saying, okay, hello, you're going from 1, then you're saying next of A would be 2, next of A will be 3, and next of A will be 4. That means once I go here, can I access the data before all of that load? No. Okay, that's why you're not able to load anything here. And what that essentially means is when I'm going to the next of A from here, what I am doing is I'm erasing this. When from 2 I'm going back to 3, I will be erasing 2 from memory. When I'm going from 3 back to 4, I will erase 3 from the generator object's memory. That means always only one element is there, and you know what the next element of that is, and the next element is lazy loaded, which means rather than using this 4 things, 4 slots, 4 elements of all time, you can just get away from using 2. That is this element and the next element that it calls. And this element, again, as we say, is lazy loaded. So in this case, maybe you're saving 50% or so. But let's say I have a million elements, right? Even in that case, you'll only have 2 elements. One, the value itself. next is the value that is lazy loaded. So you can save a lot of memory using generators, but I think you see the caveat here that once you load something, you cannot reload it. It is lost. So once you go from 1 to 2, 1 is lost, 2 to 3 is 3 is 2 is lost, from 3 to 4, 3 is lost, and from 4 to the next element, 4 is also lost. So the next time you try to iterate over this generator, you don't get anything. Something to keep in mind is what happens internally is when you go to the last element of the generator, something called as a stop iteration. This is an exception is triggered. And once the stop iteration exception is triggered, it will no longer go ahead and visit or even try to visit the next element, because it decides that, well, my generator is over. Everything after this, there is nothing. So I will go ahead and not do anything or try to load anything after this. Now, after this explanation, the things that you need to keep in mind is this next function, next of object. This will simply lazy load next value. Okay, let's get back into the code. Okay, I hope you understand about how these generators work now, and you're able to get why we used yield here and what the use of the next function was. Now, you don't necessarily have to yield like this every single time. You can actually just iterate through all of this and get something like, okay, so I'm going to define a number generator, and this will again take a list as an input, and what I'll do is just iterate through this list and it will yield that value. Okay, now I'm going to go ahead and create a generator object, and this object will be numgen of, let me provide my list 1 2 3 4 and 5. Okay, that's it. The object will be created now. Then and I print this, you can see the generator object is created. Now, let us go ahead and iterate through this generator object, and I'm going to show how this looks like. Okay, now I am going to print, and we looked at the stop iteration function also, right? So let's say what that looks like. Now, there are two different ways I can use this. So we talked about the next function. We'll start with that. So what that will be is, I have this generator object right here, right? So what I'm going to do is, I'm going to do while true. Okay, I am going to try something. So try means except, and since we got the stop iteration exception, we can use that thing. Okay, so what I'm going to do is, I'm going to do a is equal to next of my generator object, and that will be the element I have. Okay, a might be let's just put el. Okay, that will be the next value. I'm going to go ahead and print el. Okay, now, and let's say after we get through 1 2 3 4 and 5, I will have to stop this iteration, because once that throws me the stop iteration exception, we can break this for loop. Once this gets, simply do the break function. Okay, and okay, I can actually said we can actually print iteration stopped, and then we can go ahead and break. Now, if I run this thing again, you can see that prints 1 2 3 4 5, and iteration has stopped. Now, I'm going to go ahead, copy paste this, so that this object is created every time I run. If I don't paste this, what happens is the next time I run this, it'll just stop the iteration, because this is already exhausted. So if you want to try this code out, and if you want to run this cell, just put this over here, so that every time a new generator object is created. So this method 1 to iterate over a generator. Okay. Now, there's another method also. What does method 2 look like? And I'm going to copy the same code. I'm going to paste this down below. I'm going to keep this line alone, because you can generate that generator object every single time. But now what I'm going to do, I'm going to do for I in generator object. I am going to go ahead and print I. You can see that 1 2 3 4 5 prints. Internally, what happens when I do this is, it goes to the next function. It calls that internally every time this for loop is executed. With every iteration, it calls that next function, and when it stops iterations, it'll just stop. Okay, that is what is happening here. This stop iteration exception is handled inside itself. So that means, let's say I have this generator object and I run this again. You can see that nothing comes. That's because the stop iteration function calls the next time that it goes through, and it will not print anything. Okay, if I run this like this, you can see 1, 2, 3, 4, 5 is printed. Okay, that's something that is very interesting. Is you don't have to just do yield I, because you can actually change this to anything you want. I'm going to say I into I. Okay, let's create a way to square every number and use a generator for that. Okay, so I'm going to use this, iterate over that. You can see that 1, 4, 9, 16, and 25, which are the squares of 1, 2, 3, 4, 5 is generated the same way I do here. You again see that the squares are generated, and that's the real reason why we want to use generators. Rather, one, we don't want the memory to be overwhelmed and load the entire data at the same time, but also we might want to perform some special operations over this. Combination of that is generator, because you can also perform special operations and return a list, but you're going to have to perform that operation to the entire list at the same time and return that. So that will become complexity computational wise and memory wise also. Here we can just load on the fly, lazy load these values and make the computations on the fly as well. Here's a table on what we just talked about, rather than just using an actual list and using a generator. Now, generators we use in very specific cases, and we have a set of aspects here on why this will be better. Okay, so memory usage wise, it's very low compared to list for large data, which is what we talked about all this while. Speed wise, this loads lazy and this loads eager. Eager means all of that is loaded at the same time. Reusability, well, generator is not very good at that because it can only use once and then it's gone. But list is reusable. You can print the same list how many ever times you want and it will print. Okay. Flexibility wise, this can be paused and this does not pause and it just stops. What does that mean? When I'm returning this list here, it'll just return the entire list. What if I only want to return half the list and then I'm done with that? Well, you can't do that here. Whatever value it takes, it just prints, or you can just write some code, let's say up to the third element I can return. But what if this element is something that I want to decide on the fly as well, something that I don't want to hard code? Well, you can't really do that. But you can do that here. So whenever I'm calling that next function, I can just print or halfway or some dynamic way, I can just stop and then I can pause that and I can continue whenever I want. Of course, the ones that is below that won't be reusable, but I can stop and I can pause whenever I want. That I cannot do with lists. Now, finally, let's talk about why we want to use generators. Well, as we just discussed, it's ideal for big data, streaming, or working with I/O functions, or basically anywhere we don't want to hold all the memory at once, and anywhere where we can pause and efficiently pause instead of wasting a lot of memory. So this is a quick overview over what generators are. I hope you're able to understand what was discussed here. All of this code will be available in our GitHub repository, link below. If you guys have any questions about generators or anything that I've discussed in this video, do let me know. I think I've covered at least what I wanted to. If there's some other things that I didn't cover, let me know. We might make a video of that as well. But thank you so much for watching. I hope this video helped you. If it helped you, hit that like button. I'll see you in another video. Until then, bye.